Today we're going to learn how to integrate using what's called partial fraction decomposition. Sounds a lot scarier. So goal for the day. First, we're going to make sure we can factor because you can't do today's stuff if you can't factor. And then we're going to look at how we can find A and B on the next problem, which is really the hardest part about today's lesson. You can do that today, not do that. And then the number 3 long division will come up on some problems today. So, again, today is very algebra heavy. It's just another integration technique. Relies a lot on algebra. So how do you factor the 2x squared minus 7x plus 3? Slide and divide, or guess and check. Perfect either way. 2x and x are our only options. 3 and 1 are our only options. We just have to organize them correctly so that when we multiply inner and outer terms, they add to give us negative 7. Questions about that? Do I need to slow down on that? Good. Okay. Find A and B. I'll skip that one. We'll come back to that one. Go on the page for different shapes and ways. Let me see what you did first and then show you the rest. Let's do long division. Ask us to rewrite this as the quotient plus the remainder over the divisor. When I'm dividing, what goes where in long division? Okay, so even in regular long division, if we had 3 divided by 5, right? We would put the 5 on the outside and the 3 inside. Agree? Any questions so far? You may remember from long division, you ignore the last 2 pieces and you ask yourself x squared times what gives you x squared? And what would you say? 1.
Is anyone swerving in here? Your mom.
Okay. Alright, any questions so far? Multiply that down and I get x squared plus x minus 2. I do subtract everything. If you remember from long division, if you messed up any step, that was generally the one you messed up, forgetting to subtract everything. The x squared is canceled, the x's canceled, and I'm just left with 3. Does x squared go into 3? No, so that is the remainder. Then I asked me to write this as quotient plus remainder over divisor. Which part is the quotient? The 1. The answer. The remainder is 3 over the divisor. It turns out that that original is completely equivalent to that. Those are completely equivalent answers or polynomials. This format will help us today in integration. So that's why we needed this, was so we can use it in integration. So we will have a couple where you have to do it. Okay, find A and B. How did y'all do that? Got a common denominator on the right. And so you get A times x minus 4. How many of you were able to do this? Awesome. That's half the battle of today, if you can do that. Today's easy. X times B. Everyone agree? I have gotten rid of the denominators at this point because why did I get rid of the denominators at this point? They're all the same, so if these 2 fractions are going to be equal, the tops have to be equal, so I can kind of ignore the denominators. And then what did you do, Logan? Did you get an actual number answer? Did anyone actually get a number answer? What did you do?
I just plugged numbers in until I got them on both sides to kind of equal each other.
Okay, what numbers did you choose?
I just put x in as 6, and then that way
you tried some?
Yeah.
Okay. What'd you do?
I distributed the A into x minus 4. And since there are two x's coefficient in front of it, I knew that there's only one actual number. It had to be at least 12, so A had to be 3. And then since you have 3x and you just got 1x, B would have to be negative 2.
How did you get
That
x minus 2?
it needs to be flipped.
Okay, sorry. You're right. I can see how that would be confusing. Okay, there's a couple of methods. One of them is just the algebraic method, which y'all have all kind of taken an algebraic approach just by thinking it through, although the method that Fatima used is the most similar to my favorite method, which we'll talk about in a second, except you choose numbers very wisely to make it quick. But the first thing I'm going to do is just show you the oracle algebraic thought process behind this. I end up getting ax plus bx minus 4a. Wouldn't you agree that the a plus the b would have to be 1? Because the x's are going to have to combine to give you that x. The x's on the left, those are going to go together. Have to equal the x on the right. So ax plus bx equals 1x, or a plus b equals 1. And then the other piece of that is that means negative 12 would have to equal negative 4a. Right? Which I think is someone has said that. Negative 12 has to equal negative 4a because they're the only constants involved. And so I could find out from that a must be 3, and then I can plug that in over here and find b. What'd you say? Negative 2? 3 and
Just get 3
3
negative
and negative 2. This is the way that I learned in high school, whenever I learned integration by fractions. I think it was in high school. I'm not really sure. That's what this is the method I learned. There's another method what's called the Heaviside method. It's because a guy whose last name was Heaviside, you can read about it in the textbook, came up with it. It's quite clever, and it's very similar to what Fatima was saying. X minus 12, x minus 12. I'm going to go ahead and write this. B times x, right? I'm going to go ahead and write x minus 0 just for future, because it could have been something more than just an x. Okay. Any questions so far? So I just rewrote it. Start there. Now Fatima said just plug in a 6 and she plugged in some things until she figured out a and b. The fastest way to do that is to plug in 4 into every x. Why is 4 quick? What's going to happen? It's going to make this whole term 0, isn't it? Then I'm only going to have a b involved. That makes it quick. 4 minus 12 equals b times 4 minus 0. Very clever thought process. Negative 8 divided by 4 is sorry, that's not negative 4. Try that again. Negative 8 divided by 4 is negative 2 is b. And then, how do you think I could find a pretty easily? Plug what in for x? Plug in 0 for x. If I do that, plug in 0 for every x, I get negative 12 on the left equals a times negative 4. And what happens to this whole piece? It's 0. So what's a? 3. So this is a very efficient way to find a and b on what's called a partial fraction deconstruction. It's called the Heaviside method. I love it. I don't like tricks and shortcuts, as you know, but to me this is not a trick or a shortcut. It's algebraic. It just happens to be a fast algebraic way to do it. So simplify this at first glance.
U substitution.
U substitution, so try that. I would try the denominator as U, but the numerator is not 2x plus 3. If the numerator were 2x plus 3, and why in the world, and where in the world did I get 2x plus 3? The derivative at the bottom. If the numerator is 2x plus 3, please do not use partial fractions. Just do a U substitution. It works wonderful. Do it. But unfortunately, this one doesn't work with U substitution. I have no way of dealing with an x squared in the denominator, so I'm stuck. But if I could break this into two fractions, then maybe I could have a chance. So step one, I'm going to factor the denominator. What is that denominator factor to?
X minus 5.
X plus 2. Almost. X plus 2. Good. And how did what was I looking at when I decided I needed to correct it slightly? 3x is positive, so that would be 5. What I want to do is deconstruct this fraction into two different fractions, the same way I did that last piece. I'm going to do a side note. I want to know the two numbers a and b, where those two numbers give us this fraction when added together. Now let me tell you a couple of things about when this works. This only works when the numerator is 1 degree less than the denominator. That's why you may have to do division to get it in this format, to be able to work with it this way. But a and b should just be numbers. And if a and b are just numbers, then my antiderivatives on these would just be a logarithm, which is nice. I can work with that. So I need to find a and b. You will get to where you don't write all of this down. You'll kind of skip some steps here and there. But we're going to write everything today. So I want to know 4x plus 41 equals a times x minus 2 plus b times x plus 5. What are a and b? Any method you used on the bell ringer, you can still use. Just because I'm showing you the heavy side method, which I think is quick. If you like something else better, this is just algebra. You can do it however you want. But what could I plug into x to quickly find b? 2. What could I plug into x to quickly find a? Negative 5. So 2 and negative 5, I'm going to plug those in for the x values. Did everyone see why I'm choosing those? Any questions about why I'm choosing those? Good. Okay, so I'm going to plug in 2 for x. And I get 8 plus 41 equals b times 7. Did I go too fast on that? Are we okay with? Okay. So 49 equals b times 7, or 7 is b. On the right, or on the other piece, I'm going to plug in negative 5 for x. If I do that, I get negative 20 plus 41 equals a times negative 7. Any questions on that? That's 21 divided by negative 7 is? Negative 3, is that what you said? Any questions so far?
Where'd you get negative 7?
Negative 5 minus 2. So I plugged in negative 5 for all the x's. This goes away, it's just 0.
Oh, okay. Yeah, I see.
whatever I don't finish today/work. Maybe. We'll see how fast I go. I don't want to go too fast. Any questions so far? So we have the integral of -3 over x plus 5. Why -3 over x plus 5? What am I doing?
Plugging in -3.
This is completely equivalent to that with this a with the a and b we found. So I'm plugging in the -3 to that a and the 7 into the b. So 7 over x minus 2. Is that a doable integral? The first piece of it, now you could separate it. I'm going to separate it one time after this. You'll probably not want to separate it. But this could be separated into the integral -3 times 1 over x plus 5 plus 7 times 1 over x minus 2. Does everyone agree that that's the same integral? The derivative of x plus 5 is just 1, so that's one that I can just do a regular logarithm on without a u substitution. And so I just get -3 natural log the absolute value of x plus 5 plus 7 times natural log the absolute value of x minus 2 plus, this is integration by partial fractions. Any questions about that? I cannot do this one at first. Why not? The numerator is not 1 degree less than the denominator, or in general smaller than the denominator. The numerator has to be smaller than the denominator, degree-wise, and it's not. So how do I make it that way? Divide it, long division. And I would ask myself, x squared times what gives me 2x cubed? You probably wondered in Algebra 2, when synthetic division was so nice, why we still made you do long division. This is an example. I can't do synthetic because it's more than just x minus 3 as a divisor, so I have to do long division. It only comes up in Cal 2, but it comes up eventually. 2x times x squared minus 4 would be 2x cubed minus 8x. What do I have to do to both of those? Change the signs because I want to subtract them both. These cancel, and I get 8x. Does x squared go into 8x? So that is the remainder. So that means this integral is equal to the integral of 2x, that's the quotient, right? It divides to equal that, plus 8x over x squared minus 4. The 2x portion of that integral I can do just fine, no problem already. What's the portion of that integral that I need partial fractions on? The second portion. Even though I'm going to keep the first portion around, the second portion is the part that's the work. Does the denominator factor? X plus 2x minus 2. So I want to know, side note, what's A and B? And so, now again, you'll get to where you don't write all of this out, but the only difference is they have one logarithm first and the other, but in addition. So we have 8x equals x minus 2 times a plus b times x plus 2. Common denominators to get that. What are the two numbers that will make this fast using the heavy side method?
Negative 2 and 2.
Negative 2. So I'm going to plug in 2 for x. And I get 16 equals b times 4. You can probably see some ways you could shortcut how much you write down on paper. Do whatever works for you. If you want to write it all out, write it all out. If you want to kind of shortcut it here and there, do so.
In this case, you don't have to use enough. You don't have to write anything else because you know that A has to be the opposite of that.
Like in negative 2. Negative 16 equals negative 4 times a. And I still get 4, don't I? Any questions about that? So I have the integral of 2x. Where's the 2x coming from? It's just hanging out there, right? Because the division we did. Plus, what did I put? There's x minus or x plus. What was the a over?
X plus.
Not that it matters on this one, because they're both 4, but sometimes it does matter. And now I can integrate all 3 pieces of this pretty easily. What's the integral of 2x? What's the integral of 4 over x plus 2?
4 natural log the absolute value of x plus 2, and then plus 4 natural log the absolute value of x minus 2.
Perfect. Any questions? Very long, very tedious. Of course, we do not have to do 10 of these on the AP exam. But not the hardest thing you've probably ever done either. So, both days, both yesterday and today, both tedious, not necessarily strange, challenging. It would be if you weren't good at algebra, but if you're good at algebra, these are very algebraic. Yes. No, we're actually done with the material. The next few are ones I just want you to think about. Not, I mean, for today. Not forever. But, are they going to, on the BC exam, when a problem comes up, are they going to say, hey, this is a partial fraction problem, do that? No. You're going to have to make that choice, right? So, I have 2 integrals up here. One you have to use partial fractions, one you don't. You tell me. What do you think? First one you don't. Why? The numerator is the derivative of the denominator. I can use a U substitution, so let's do it, because some stuff you might need to substitute. So let u equal x squared minus 4. Du would be 2x dx. So this is the integral. By the way, that would be 1 over 2x times du would be dx. Of 2x over u times 1 over 2x d. 2x's cancel, and I get natural log of the absolute value of u. But what was u? I'm not saying this problem couldn't be done with partial fractions, but would partial fractions take you longer than that? So just mental note. The next one is one you have to use partial fractions on. We'll do that one tomorrow. Let me do one more page of, do we need partial fractions or not? Will anyone see all the people who are out? You will? Okay, grab extras if you will see someone that might want to. If not, just bring it down.
No, what are they supposed to be? One has like the classes.
What do they possibly be doing? Cleaning up the tables and stuff at lunch. This is due on Friday.
Oh, yeah.
This is due on Friday.
Oh, it's weird.
Hey, and because y'all have been kind of bad about not doing work, let me give you something I want you to do tonight. On the multiple choice, do whenever you want, but skip to the one that's like it looks like a worksheet attached. 1 through 6, 8, 11, and 12. 1 through 6, 8, 11, and 12. Those to 9. I'm laughing this for you. You should have said 6, 8, 11. Do the 11 tonight. Do the 11 tomorrow. Do more if you wish. Please do, but it's testing. I know. It won't. Nothing, no testing, not even mastering before Thanksgiving. We'll just be learning until Thanksgiving. Test will be out. We will finish the new material or almost finish it by this Thanksgiving. It's exactly what we need. Okay, one of these you need partial fractions and the other one you don't. And this one's tough because it's something I haven't made you memorize yet. I just made my AV class memorize it today. One.
Yeah.
Yes. And it's 1 on the top. Yeah, if there's just an EX on top, that means it's a 1 on top. So you'll just take it.
I didn't get it.
And I have more. I haven't made you memorize these derivative rules yet. So it's going to be a little harder for you to figure this out, but so I'm going to help you a little bit. So we only have 3 minutes. Get your new calculus helper out. You know which one I'm talking about? The AP calculus. It's not like calculus helper. Yeah, it looks like this. Turn to the derivative rules and look at the derivative of arc tangent. What is the derivative of arc tangent? What is the derivative and you can but do 11 problems tonight, because I'm not liking the way y'all do nothing one night and then come in and have to do all of it. I don't like that. Do some. I gave you 11 extra problems that should be pretty easy. Tomorrow we'll pick up one of the ones with 3 parts. Any questions? If you do a different 11 than I asked you to, I will forgive you. That's okay. But do 11. I just picked out 11 pretty easy. Any questions? How do you feel about partial fractions that start at the easy? Not too hard. Process.
Like yesterday, but without